Hello everybody. So now we are gonna see, after we understood how we can figure out if the R minimum is right or wrong, we can now go to the next step, which is finding the right value of R minimum in case of having an R minimum that's not right. So what we said in the previous video is that we did got some values of x, and then we checked if the operating line will be above the equilibrium curve, and we were able to get this done. And now the next point is to do the calculations to get the right value of R minimum. And this is, if you're using a pen and paper, then this is gonna be very simple. You can just visually see that this point would have, or would cut a tangent if the line starting from here should be tangent to this point. This can easily done visually, and then when you connect this to this, there will be no other intersections here, so this line would be the R minimum that we are gonna use. So this is what we mentioned in the previous video, and now let's go to the this part. So now we will do this visually, but with Matlab you need to do something to let Matlab understand that. And what what I suggest is that you can simply increase the value of R minimum. You'll do a loop to increase the value of R minimum and do this check again. So when you increase R minimum, you're actually drawing more and more lines and doing the check for each of these previous lines. You still have the check. The check is giving a value that's greater than 0, and then this means that this R minimum is not right. So you increase the R minimum more and more and more until you reach a point when the check is not greater than 0, is 0, and then it's gonna stop, and then the value of R minimum that you get is the true value of R minimum, and this is what you're gonna get from here. So this is simply what we are gonna do. So let's go to Matlab and then see, let's see how we can do this. So this if condition that I did last time is useless. Actually, I'm not gonna do anything with it, so I'm deleting it. And now let's see. So we now have something that we need to check on, and we do loops. When you are checking on something using loops, you are using a while loop. For loop is not gonna be the good thing to use here. So what I'm gonna say is that I'm gonna check, I'm gonna check on the R minimum check, which is this. So while R minimum check is greater than 0, what we're gonna do is increase the R minimum. So I'm gonna add R minimum equals R minimum plus, I would increase it with 0.01. You can make it, if you need more accuracy, you can make it 0.001. It's not a big deal. Let's go for 0.01 and see what's the difference. And then we need to recalculate the R minimum check, because this was calculated from the previous value of R minimum that was calculated before. So I need to recalculate it. And there is one other thing here. If you're going to write it this way, so you might think of it like this way: the R minimum check is gonna be greater than 0, then it's gonna increase the value of R minimum, calculate the R minimum check using the top section R minimum equation and the Y equilibrium equation. So the Y equilibrium is nothing is gonna be wrong with it, but for the top section R minimum, top section R minimum is actually calculated from here, which is based on the value of R minimum that was calculated before. So you need to re-put the top section before the R minimum check. So this is necessary to do this. Otherwise, it's gonna go for infinite loop, because you're increasing the value of R minimum, but the top section is not calculating the Y based on the new value of R minimum. It's calculating it based on the old value of R minimum. You can try it, and you'd see that what I'm doing is, or what I'm saying is right, because I've already did this mistake, so I know that this happened. So now that's all. What you're gonna do now is just to run the file. So again, let's go quickly through what it's gonna do. It's gonna do the check. based on the value of x check between the pinch point and the xd, and then it's gonna see if this value is greater than 0 or not. The good thing about this code is that it's not gonna work if the R minimum check is 0. So if the R minimum you got before is right, then this is not gonna do anything. So this is gonna work only if this is greater than 0. So for ideal equation, this is not gonna work. It's gonna be useless. So it's gonna check if our minimum check is greater than 0, then it's gonna increase the value of our minimum. The top section is based on the new value of our minimum, then the our minimum check is calculated based on the new value of our minimum, and then we should reach some good value. So let's I think nope, it's not calculated. So the previous value of our minimum was 1.08. I think this is the one that was calculated with the wrong R minimum. So when I run the file now, oh, this is for the ideal case. So this is one good thing actually about this code, that I said it's not gonna matter if it's working for ideal or non-ideal, because for ideal this is not gonna work. But now let's shift to the non-ideal. I'm gonna use equation 2 and then run the file, and you see now this is what I'm saying. Let's focus on from 0.9 to 1. This is exactly what we got. We have the R minimum 1.5488. So you have, this is the tangent that you get at this point. Okay. So now let's try one other thing. Let's go again, the R minimum 1.5488. If you want to get more accurate results, you can make it 0.001. So you're increasing with an increment of 10 to the minus 3 instead of 10 to the minus 2. And if you run the file, it's gonna be 1.5468 instead of 88. So it is not a big difference, but it is giving kind of more accurate results. Again, if you focus on the axis in this part, you'd see that it is giving the tangent here at 96%. So this is exactly what we need to do to get the actual value of our minimum. Everything else is gonna work the same. You don't need to do anything about the top and bottom section lines. The next video you'll see how can we deal with the stages. If we need to do the stages for the top section and bottom section, what difference would be important to do or to fix in the code so that it works based on the new equilibrium curve, which is this one. So I'll see you then, and goodbye.